All right, so we are going to work today on graphs of tangent and cotangent functions. And although that tangent and cotangent involve sine and cosine, the graphs are very different. We saw with sine and cosine we had a wave, and to get secant and cosecant we had to draw the wave first, and then we based our graphs off of that wave. But tangent and cotangent have totally different looking graphs. So I draw a unit circle that I'm going to reference here in a minute. And actually, if we look at our unit circle, and it's a little crooked, but I put some basic points on here at all the axes. So if I look at tangent, which is sine over cosine, okay, or the y coordinate over the x coordinate, the tangent at 2 pi or at 0 would be 0 over 1, which is 0. Okay, if I go to pi over 2, I'm going to have 1 over 0, which is undefined. Back over to pi, I have 0 over negative 1, which is 0. And down here at 3 pi over 2, I'm going to have negative 1 over 0, which is also undefined. All right, so just looking at those x and y intercepts, we can see that at pi over 2 and 3 pi over 2, we are going to have values that are undefined. All right, so undefined here and undefined here. My highlighter was a little dark, sorry. So if I look at some properties of the tangent graph, and this is just the in function form, we're going to look at a tangent graph. A is still the amplitude, B affects the period, and C and D are just horizontal and vertical shifts. All right, so in the properties, it says first that the domain is the set of all real numbers except for odd multiples of pi over 2. All right, that's important. And it is at the odd multiples of pi over 2 where tangent is undefined. And this is where we're going to get our vertical asymptotes. And the range is a set of all real numbers, unlike all the other trig functions where you had a set of numbers either between negative 1 and 1, or for sine and cosine, or secant and cosecant were greater than 1 or less than negative 1. But the range here is all real numbers. It says the tangent function is an odd function. That means it's symmetric about the origin. And another thing that's different with tangent is that the period of tangent is pi. That means from 0 to pi on my unit circle, we will see one full revolution of tangent. All right, so in all the other 4 trig functions, the period was 2 pi. Okay, here the period is pi. So if I look at this example 1 down here, let's put all this together. I'm looking at the amplitude first. My amplitude is going to be 1 because that's the number multiplied here. My b value is the number that's multiplied by x, which is 1. So my time that it takes to do one cycle is pi over 1, or just pi. And if we look what happens here, tangent is not a very nice graph. So if I have 0 and I'm going to have pi as 1 revolution, I have at pi over 2, and I'm going to go in both directions here. So here's minus pi, and here's minus pi over 2. So at any odd value of pi over 2, I have a vertical asymptote. So one period of tangent is going to happen between two vertical asymptotes. All right, so I could have another over here. I could have a 3 pi over 2, which would also give me another vertical asymptote. All right, so we know, and let's do my amplitude here is 1, here's -1. So we know at 0 degrees, and back up here at my unit circle, at 0, tangent is 0, so I can color that in. At pi, tangent is 0. At negative pi, tangent is 0. So anytime I go around the circle, every pi, I'm going to get a tangent of 0. So pi is 0, 2 pi is 0, 3 pi is 0, 4 pi is 0, and I can keep going. All right. Every odd multiple of pi over 2 is an asymptote. Now, another thing that we know with tangent is at 45 degrees, or pi over 4, put that here, we're going to get the square root of 2 over 2 over the square root of 2 over 2, which is 1. So if I still need my 5 points in between for one period, so I'm going to say this is pi over 4, this is 3 pi over 4, 4 pi over 4, this is 5 pi over 4. Back here would be negative pi over 4. All right, so at pi over 4, my tangent is 1. So at pi over 4, I'm going to go up here to 1. And at negative pi over 4, that would be this way. And here, my tangent is negative. So this would be -1. So my graph will look like this. It's going to go and hit the asymptote. Oops, it's going to kind of curve here. Same thing here. 3 pi over 4 is negative. 5 pi over 4 is positive. So it's going to look like this. All right, so I'm only going to ask you to graph one cycle of tangent. So in this case, I would start, okay, and I'm going to kind of look at this cycle in here. I'm going to start at negative pi over 2, and I'm going to end at positive pi over 2. Okay, that would be one cycle. All right, let's do another one. The next one, I have tangent, or 3 times tangent of 2x. All right, so let's identify what we know. We know that our altitude is 3, and our time to do one cycle is just pi over b, which in this case is pi over 2. All right, so I'm just going to start here. Let's see what this looks like. So to find where I'm going to start, I need a cycle of pi over 2. And if I cut my length of my time in half, I'm going to start at pi over 4 and the negative direction, and I'm going to end at pi over 4 in the positive direction. All right, so here is, let's do pi over 2 way over here. Let's spread out a little bit. Okay, so I could do this from 0 to pi over 2, but at pi over 4, halfway, I'm going to have this vertical asymptote. Okay, so this is pi over 4. At negative, I'm trying to be, pi over 2, halfway would be negative pi over 4. And again, I'm going to have another vertical asymptote. All right, so here, my altitude is 3. So instead of going and having a y-intercept, or having that value at 1 here, I'm going to go up higher and have it at 3. So tangent of 0 is still 0. Now I need these values in between negative pi over 4 and pi over 4. And I've noticed in homework we're not labeling our axes very well, and this is going to take some practice to do this. So you have to label your x and y axes to get full credit for this on a test. All right, so halfway between pi over 4 is pi over 8, and this would be negative pi over 8, 2 pi over 8, here's 3 pi over 8, and I'm really only concerned with in between the two asymptotes. So I'm going to go from negative pi over 4 to pi over 4. All right, at this first point here, halfway in between 0 and negative pi over 4, I'm going to have a negative 3 as a point. And here I'm going to have a positive 3. So my graph is going to look something like this. All right, so there is your graph. All of your tangent graphs are going to take on this shape, but the most important thing is that you have to have the axes labeled properly. All right, let's do another tangent one. This time I have an altitude of 2, and this is a shift, and we haven't done a shift yet, but this is going to shift down 1 unit. This is a vertical shift. Okay, so instead of going through the origin here, if this were a -1, everything would shift down 1 unit. So instead of here at -3, I would shift it down, and then it would come up here and then follow that pattern. All right, so that's going to happen here. My period, or the time for one interval, is pi over b, and b is 1, so this is pi. So I know that I'm going to start and end at half of my period. So I'm going to end at pi over 2, and I'm going to start at negative pi over 2, just the opposite over the origin. All right, so if I draw this, right, so let's get our asymptotes. So here's pi over 2, and here's negative pi over 2. And at those points, I'm going to have vertical asymptotes. I know that, let's get our points in here. Halfway in between pi over 2 and 0 and negative pi over 2, this would be pi over 4. Okay, so 1, 2, 3, 4, 5 points here. My altitude is 2, but because I'm shifting at 0, 0, I'm going to go down 1. At pi over 4, if my altitude were 2, this would be negative 2, but since I'm shifting it down 1, it would be negative 3. And this one would be at positive 1. So it's going to kind of look like this. And there you go. There's one cycle of tangent to tangent of x minus 1. All right, now let's look at cotangent. Cotangent is very similar to tangent. Let's look at a quick unit circle here. Or actually, I can just bring in the other one. So in this case, for cotangent, I'm just going to write up here, we're going to have x over y, because tangent was y over x. So cotangent is going to be x over y, which is cosine over sine. And cosine over sine at 0 would be 1 over 0, so it's undefined at pi and undefined at 2 pi. Okay, so it's kind of the opposite of the tangent ones. It's where tangent was undefined at odd multiples of pi over 2. Cotangent is going to be undefined at any multiple of pi. All right, so any multiple of pi is going to be undefined. So I'm going to write that on this. Cotangent is undefined at any multiple of pi. All right, so this is a little bit nicer of a graph because when I'm graphing, first in example 4, I'm going to graph cotangent of x. So I can draw my axes, and at any multiple of pi or 0 pi, let's do this. So here's pi. Here's negative pi. So I have vertical asymptotes here. All right, so my period, instead of going from negative pi over 2 to pi over 2, I can just go from 0 to pi or negative pi to 0. I don't have to do those half-z's in this one. But I do know that my amplitude is 1, my b value is 1, so my period, or my t, is still pi over b. In this case, b is 1, so this is just pi. So I'm going to start at 0, and I'm going to end at pi, okay, from 0 to pi. And if I think of where cotangent is 1, I'm going to bring back that unit circle. I still have the square root of 2 over 2 here at pi over 4. Okay, this is still 1. So at pi over 4, I have a cotangent of 1. So here's pi over 2. At pi over 2, my cotangent is 0 divided by 1, so that's 0. So if I break these up, this is pi over 4. This is 3 pi over 4. So cotangent of pi over 4 is 1. So here's 1. That's my amplitude. So I'm going to have 1 here. And at negative 3 pi over 4, it's going to be negative 1. So that would be about right here. So my graph will look like this if it goes through the points. All right, if I did another period over here, this would be negative pi over 2. I would have 0 cotangent there, and this would be negative pi over 4. This would be negative 3 pi over 4, and here I'm going to have a 1, and this is a negative 1, and it will look like that. All right, so cotangent of x, this is our graph. All right, let's do a little bit of adding some stuff to that. Here's my altitude is 4. My t is pi over b, and in this case b is 2. So pi over 2 is going to be my period this time. So I'm going to start here. I'm going to start at 0, and I'm going to go to pi over 2. Okay, so this will be one cycle from 0 to pi over 2. So start at 0 and at pi over 2. So I have my vertical asymptotes here. Halfway between pi over 2 is pi over 4. And then I have a pi over 8. And this is 1 pi over 8, 2 pi over 8, 3 pi over 8. At pi over 4, I'll have a value of 0. At pi over 8, what's my altitude? It's 4. 1, 2, 3, 4. So at pi over 8, I'm going to go up 4. And at 3 pi over 8, I'm going to go down 4. And then I can draw the graph in. All right, so those are the graphs of tangent and cotangent.